Ever wondered how AI transforms a simple text prompt into a breathtaking image, or deciphers the story behind a photo? Today, we're diving into LaTtE-Flow, a groundbreaking model redefining AI's speed, intelligence, and efficiency in handling both vision and language. Let's unpack this innovation. Most AI systems today are like single-task specialists. One excels at describing images, another at generating them from text, but they're siloed. LaTtE-Flow changes the game by unifying these capabilities into a single, hyper-efficient framework. Think of it as AI's multitasking superpower. But here's the challenge. Existing unified models often hit a wall. They're either sluggish, like a chef juggling multiple dishes at once, or they compromise quality for speed. LaTtE-Flow solves this by reimagining how AI processes information. Let's break it down. At its core, LaTtE-Flow uses Layerwise Timestep Experts, a system where specialized experts tackle specific stages of image creation. One expert might focus on sketching basic shapes, another on textures, and a third on refining details. Instead of overloading the model with all tasks at once, it activates only the relevant expert at each step. It's like a well-orchestrated kitchen. Each chef knows their role, ensuring the meal is both faster and better. This approach slashes unnecessary computations. Imagine a roadmap for the AI. You only need this tool right now, save the others for later. By dividing work into specialized time steps, LaTtE-Flow accelerates processing without sacrificing quality. But there's more. The model employs Timestep-Conditioned Residual Attention, a mechanism that lets it learn from its own past steps. Picture a painter reviewing earlier brushstrokes to guide the next. LaTtE-Flow does the same. It remembers what worked in prior steps, using that feedback to refine later outputs. This creates sharper, more consistent results. The data speaks volumes. LaTtE-Flow generates images up to 6 times faster than competitors while maintaining state-of-the-art quality. By optimizing its architecture, it reduces computational load, making advanced AI feasible on devices like smartphones or edge computers. Why does this matter? Faster AI enables real-time applications. Think instant image generation for virtual assistants or adaptive AI tools. It also democratizes cutting-edge tech, bringing powerful capabilities to hardware with limited resources. LaTtE-Flow isn't just an improvement, it's a paradigm shift. By rethinking how models process information, researchers are unlocking new frontiers. Imagine a future where AI is both intelligent and efficient, seamlessly integrated into everyday life. Now picture this, you're painting a masterpiece. You start with broad strokes, layer colors, then refine details. LaTtE-Flow works similarly, but with code. It breaks complex tasks into smarter steps, grouping 28 layers into 7 per stage. It's like painting in sections. Finish one part before moving on, saving time and energy. Researchers tested LaTtE-Flow on ImageNet, a vast dataset of real-world images. The results? It's significantly faster without sacrificing accuracy. This means systems powered by LaTtE-Flow could run smoother on phones, games, or self-driving cars, where speed is critical. It's not just about faster code. It's about making AI practical in the real world. Next time you see an app that reacts instantly or a game that runs flawlessly, you might be witnessing LaTtE-Flow's impact. Science isn't just about big breakthroughs. It's about smart, efficient steps that make technology work harder for all of us. Thanks for watching. If you're curious about AI's inner workings, hit subscribe for more deep dives. What's one thing you'd love to see AI create? Let me know in the comments.